Recording, yeah. So, my name is Renaud Bedard. I'm a programmer at Polytron, and I've worked on FEZ. So, about me. So, thanks for coming first in such great numbers, especially since there's Indie Game the movie showing soon, and you're here, so that's cool. And anyway, if you're here, probably want to attend Indie Game the movie afterwards on the same floor somewhere else. So, this is the technical postmortem for FEZ, which is due shortly for Xbox Live Arcade. I've always been programming, but always, like from, high school. I started doing 3D programming with Visual Basic 6, of all things, an engine called TrueVision 3D, which I don't know if people know here, but it used to be really good until like the good tools came in, like Unity and XNA, and anyway. So I started doing 3D stuff out of interest, just because I wanted to make games, and 3D seemed like the thing. And I mostly toyed with visual effects and shaders, trying to get like the right look without knowing much about game mechanics. It's just trying to make stuff look good. And I met Phil on the internet on DeviantArt because he wanted, like I was following his stuff. I thought his art style was cool. And he needed a programmer for a project that he had a really good idea, but he couldn't do any of it. And last programmer fell through. So I wanted to make a game, my first game around this time, and I was interested in its visual style. So we started making something, and then 3 months after IGF 2008, big like revelation, and then lots of recognition all of a sudden, which was really good. And from that, like we decided to form Polytron, and this is like my first full-time industry job. And I've been working on that for 4 years, nearly 5. So about FEZ. If you're here, you probably know what FEZ is, but still. It's a 2D, 3D exploration puzzle platformer. So it's a platformer. And Phil likes to call it a Mystroidvania because it borrows elements from Myst as it's very puzzly and cryptic. And so the art style is pixel art, but it's also the fact that every pixel that you see kind of is a 3D pixel. We call them trixels. They're totally voxels. The platforming is in 2D, but it's flattened across four horizontal views, or 2D views. And they're all orthographic, in which it's always on the axis, but from 4 sides. And it's built in XNA and C# from the start, and it's been actually spanning from 1.0 refresh, which is a long time ago, to 3.1. We didn't port to 4 because we had the option not to, and it was just too complicated to do it. So to give you an idea of what the world like in action, this is footage from FEZ. There's sound in this. I don't know if we can turn it a little bit up. So platforming is pretty realistic. It's not floaty or super Meat Boy-y because we don't feel like Gomez is a ninja. He's just walking around and exploring the world at his own pace. And the goal in the game is to collect these golden cubes to form back an ancient artifact that's been broken as you start the game. Gomez has like this initial incident of breaking the world, and he needs to rebuild it. So there are some interactive levels. The world seems pretty static as it is there, but as you follow through the world, stuff gets more complicated and moving parts. And it's all based on navigational puzzles in which you just try to find your way up. That's usually the direction to go is up. But it's hard to go up because you can't just run up there. You need to go around the world to get up. There's some inside parts. It's not always outside. And you open these treasures and all this stuff. Actually, wait, because there's a part where it gets interactive, so let it play. I mean, more dynamic. You'll see. And this is Dot. I'll talk about her later. It's your fairy thing. So this is one of the levels where stuff actually moves, which gives for more interesting navigational puzzles. That's about it. I'll skip ahead. So how does the world work? The world is actually an interconnected network of levels. There's about 150 of them, but some are much bigger. Some are like hubs, and then it separates into the smaller ones. Like you get a village with a ton of inside rooms, and they just collapse into this big map that you see on the side. To give a sense of place, the level transitions are like in the sky, so you know where you're going and where you're coming from. So that's what you see in the video there. It'll loop back. So so each level is isolated, but it's still an open world. You still have to traverse it and kind of explore it as a whole. The level and loading and setup happens during the transition in that case, so it's threaded. And But yeah, the map on the side is isometric, and it's kind of hard to see, so you have to rotate to move around, which kind of makes sense in the context of the game when you have to rotate to make sense of everything. So you probably saw that the levels in the game are built out of all these tiny cubes, which we call, trixels, but also tiles. And that was made because it makes sense when you're doing a platformer like a 2D game to work with tiles art-wise and level production-wise, because it's much easier and faster to build content with this. It didn't quite work just to have textures in FEZ, because everything is in 3D, right? So you have to have a trial set instead of a tile set, because everything is a trial instead of a tile. But it's just a naming convention. So we thought, okay, instead of doing individual little blocks, we could do big pieces of art that you just texture with big slabs of textures. But it doesn't make sense with a team of 2 people to just build all those individual assets and not reuse them. So making tiles really makes sense. So this is one of the tile sets, a trial set. And this is the nature one, so most of the green grass, blue skies levels are built with these. There's 17 trial sets in the game, and I'll go over how they are modeled and textured in the engine. So there's no palette limitation by design. It's just Phil is used to using Photoshop to build his textures. So I thought, okay, do I want to pick colors and paint them in the editor, or just have the textures ready and just apply them? It made sense for the workflow, and it's much easier just to have them ready and then apply them as cube maps instead of making a whole painting tools in the editor. So the cube maps, we call them free bloods because the algorithm is front, right, back, left, up, down. It looks like free blood, which is cool. So the tiles, a limitation of using cube maps is the fact that each tile gets flattened, the texture gets applied from each side and projected onto each side. So they need to be convex, or else everything that's concave gets applied twice. The inside parts would have double projection, which looks awkward. But it's pretty easy since the tiles are 16 by 16, they're pretty small. It's easy to keep that convex and make concave structures out of convex blocks, if that makes any sense. And yeah, the textures themselves are so small that it's not even a problem for memory usage or anything. It's 6K for a single texture. These are some tests that Phil actually used Google SketchUp in the beginning to try and figure out the visual style, how it would look. But it was good for testing, but you can't really make a whole game, make every model in Google SketchUp. The tools are not made for this, so we had to figure out a better way to produce a lot of content quickly. And that's where the trial sculpting came from. So this is how you build everything you see basically in the game from the editor. You start with a full block, and you would push faces in from the world editor to basically sculpt stuff out and create details. And all the texturing is managed externally, you just apply a cube map on that. And also the mesh is simplified in real time in such that if it were a 16 by 16 by 16 quad, it would be ridiculous. So you have to kind of manage it as you go. It could be post-processed, but it's easy to do in real time. So all the surfaces are planar, but you can still have quite a bit of detail in these tiles. And even though it doesn't seem like it would matter much, as the world is always seen from the flat perspectives, it adds a lot of detail and adds a lot of good feel to the game as you rotate. This is what makes the game special looking instead of being just cubes everywhere. So yeah, I'm going to talk a little bit about the mesh simplification algorithm shortly. The tiles are made of pixels, and I basically extract all the surfaces from them. And from a surface, you can just start from the center and kind of push the sides of the... Well, I spiral down from the center and then create the biggest full spiral I can get from that, and then push the sides until I get a single quad. The idea is to make the biggest possible rectangles in every surface, but as little of them as possible, so you have the less polygon count. But yeah. So this is how the levels are built in FEZ out of all these blocks. So I would start by just painting stuff. There's a kind of a palette chooser on the right, which has all the tiles in the tile set that have been created beforehand. And then you paint stuff, and then you extrude. It's basically like you would create a single trial, but instead of doing a trial, you're doing a whole level with those smaller grained, bigger grained blocks. So at the beginning, they're all white and then textured, where you just paint them and then change the painting if you need. You can group stuff together. You can drag a couple of tiles and move them. And you can always like collapse the world to to how the level would be seen in the game by like viewing anything on a particular axis. I'll show them in a little bit. And basically, the whole game is done from the editor, at least visually. The levels are made of tiles. The tiles are sculpted and created there. The only thing that's managed elsewhere is the texturing. It's kind of like Legos, which is kind of cool. I'm taking a long time because this is kneecapping and I'm not a level designer. I guess you get the idea. So this is what a real level looks like inside the editor, which is much better than I could get. So FEZ was built, we started working on an editor from day one because we realized, like I explained, that we needed some specific tools to make the content in the game as we wanted. So this is a couple of in-construction shots of versions of that editor. The first prototype wasn't even an XNA. It was done with a Chibi 3D in Visual Basic.net. And I was basically trying to find a way to edit all this cubic content inside an editor. And I thought, okay, so like 4 views like 3D Studio Max, but it wasn't really handy. The best way to treat this is really to extrude surfaces. So it started by being just colors, and then we added textures, but it was still not sculpted. And eventually, like the last shots you see are from the IGF 2008 level, which is a single level. So people thought like, hey, the game's complete now. It looks really finished, but it was like 5 minutes of gameplay. So I want to talk a little bit about how we did that iteration and then feature tracking in the game. From pretty much the beginning, Google Docs was the best way, because even though like I was not necessarily in the same place as him, at the beginning we did not have an office, so we needed to work distantly. And Google Docs is great because it's free, it's just available there, and you can like see everything. But it's a big to-do list, basically. We don't need to have something really complicated to track and keep track of what you're doing. So it's all about like discussion. We talked of features we wanted to do, establish a sprint, and then set the features there, mark them as complete as you do them. And tracking just needs to be as simple as you can make it, but still be intelligible so that you know what has been done and do not lose the stuff that's been done. And I actually, when I finished my talk, I asked on Twitter, like, what should I talk about? I feel I missed something. And one of my friends, Alice Effect, said, how do you deal with a designer from a programmer's perspective? And I thought about it a little bit, but so basically how we worked is Phil dictated design. I didn't feel like the design was my job, but it made things simpler for me, and I implemented. I was the guy that makes it happen, basically. I'm going to take a little sip. So as a programmer, you know what's possible. So you're the one that will say, like, I don't know, if Phil said at one point, it would be really cool for Gomez to be all in animated pixels. I said, like, I don't think that's worth my time. Well, I don't think that's worth the time. Like, it would be really complicated, really technically challenging, and there's always trade-offs. Like, it wouldn't change much in the game, and in the end, like, this is not a realistic proposition because Gomez is a 2D man in a 3D world, so it just makes sense that he's flat. So there's always workarounds to everything. And you can always say no, but you can't just say no and say, like, I don't feel like doing this. It's a discussion, and you got to realize that FEZ is Phil's game. The designer, Phil, associates with it deeply, so it's all about, like, okay, I respect you respect the fact that I have my limits, and we can make a game together. And version control, I was talking about tracking, so that's kind of related. You need to use version control. We started not using it, having like a crazy system of a network attached storage drive that we just shoved stuff on there and off of there and copied stuff from station to station, and then levels were lost, and then we said, like, what happened? I don't know. I have no tracking. So it's really cheap and it's really handy, and there's no way why you wouldn't use it. And I have to thank Nathan that convinced me to get into it. Very late, like 2010. I'm going to talk a little bit about the rendering and drawing. So the game, we established it's a lot of tiny blocks. If it were just that, there would be a lot of geometry. Like you see, this is a wireframe of any given level if we don't do anything. There's potentially a lot of overdraw because everything's rendered like face onto face onto face. You don't see anything of this. And we wanted, this is an Xbox game, we wanted to have 60 FPS on a machine that's basically 5 years old. So even more than that. So how do we do this? By culling and batching, which I'm going to go through. So the world is on a grid. Everything's very like grid aligned. And the grid is axis aligned. It's never rotated or offset. And it's very regular. So I can call stuff independently from, every tile can be ripped off from the renderer or just added splat onto it. So I am calling as the camera looks into an axis. I can only call what that camera sees really easily because it's a grid. And I always call within the view, like you don't need to recall everything every time. You just call the borders of the screen as you move. So how the calling works. So the screen is basically this grid of cells. I take every one of these cells like from the center and then move from the camera position to the ends of the world. There's optimizations like to know where the content actually is, but that's the idea. So you would start the camera depth and move, and then as soon as you hit a solid tile, you say, okay, that's the one I want to draw. And you keep that one, and then you move to the other cell. You don't need to draw anything that's behind it because you're not going to see it. There are exceptions, like, for example, these vines are also trials, but they're transparent. There's stuff behind it. So you would just keep walking as long as you see something that's see-through. There's also, like, that crate can be moved around. If it gets moved around, the stuff that is behind it needs to be visible still. But that's about it. So this is the one level without any calling, just as is. And this is how it looks with the calling. So there's 3 times less content rendered. It's much faster. And there's no visible difference from the camera look. So that's pretty efficient. Also, we need to batch stuff together because even though, like I removed 2/3 of the tiles. Oh. If I remove 2/3 of the tile, it's still like a lot of individual units to draw, and you can't just shove everything to the CPU and hope for the best. So you need to batch, but batching. Like dynamic batching is hard, but you can't just, how do I say this? So the easier way to batch is to batch by texture. So you know that each material can be, like you can make a batch with this, and I'll actually go through it. So what I use is instancing. Instancing is to take a redundant model, in which, in my case, like any given tile in the tile set that's used, and map it to a small packet of instance data. In my case, it's the position, the level, and the rotation, which can be like 4 different rotations. And then for each tile in the tile set, I can just have all the instances of this tile and shoot them as a batch. And that means I've got only as much batches as there are tiles in the tile set instead of tiles in the level, which is this is much better. So that gives me it gives me maximum 256 instances of the same tile per draw call. How do you do this? This is getting pretty technical, but I'll skip over it. So you need a static vertex buffer, which takes all the vertices in the mesh that you want to render, and then a dynamic index buffer that's like all the polygons in your mesh, but for each clone. And then an instance data buffer that's just all the data that's specific to each instance, so the offset and the rotation. And getting even more technical, but so this is in the shader. Like if you really want to do instancing, and you probably will want to if you're doing an Xbox game in the same scope or look as FEZ, or if you have a lot of redundant geometry. One cool thing we could do is, since there's so little data per instance, is rebuild the transformation matrix for each trial that I render, for each instance, in the shader, instead of giving it for each instance. So instead of having a 4x4 matrix per instance, I have just the position and the angle, and I rebuild the matrix. If you didn't understand anything, it's okay. if you were going to use it and actually found this interesting, that's even better. So there's not just tiles. There's also other stuff, which is basically made to be simpler to make levels or content. So there's also some planes. In inside levels, we use this a lot because it's easier to draw like a big slab of art than try to split it into 16 by 16 chunks and then not reuse them. So in that case, like all the stuff that's on the walls, the little posters, the cobweb, those are planes. They're just flattered like decals. And you can't really tell the difference. Other stuff that's planes like on the NPCs, all the wildlife and explosions, stuff like that. Usually all the animated content will be planes. Also there are like bigger, instead of tiles, they're just, we call them art objects. It's a big slab of art that's sculpted the same way as tiles, but instead of being 16 by 16, I just make them bigger, and I don't have them in a tile set. They're just, like these are slower, but they're useful for the bigger landmarks, and also they're just, sometimes, since they don't fit in the grid model, they can be moved arbitrarily. I can make them overlay some tiles, like all these little corner things that you see on the left. These are art objects. So they end up being really handy. And so, there's Dot. Dot is a hypercube. She rotates, but it looks like she's morphing, but that's just a consequence of the 4D rotation thing. Like, you would need usually a 3x3 matrix to do rotation in 3D. It's pretty simple to do 4D rotation, just use a 4x4 matrix instead, and you can do it like any other geometry. So the way it's projected in 3D space, oops. Did the video stop? Well, it's not worth it. So, so the way it's projected in 3D space is that everything that's farther in the forward direction is smaller, which is a really intuitive and naive way of doing it, but it really works, and it gives you a sense of something that's otherworldly or weird. And story-wise, it makes sense that she's 4D because she knows more than you. Like, you're the 2D man going in 3D world trying to discover the mysterious third direction and the dimension, and she's like one step over you, basically. So that's why she's guiding you. Collision management. So the world is mostly made of these tiles. So it just makes sense to use the tiles themselves for collision information instead of doing another mask overlay. And you can do it like every tile in the tile set has definite collision information. You have immaterial stuff, which doesn't interact with you at all. You've got no collision, which pushes you, like there are background tiles, but they would push you so that you stay visible. There's a top collide, which is most of the tiles, and all collide, which block you like inside of a house. You won't go like outside the room. So the art objects, since they're completely separate from the tiles, we actually need to fill them with invisible collision tiles because they don't have any collision information inherently to them. So the easiest way was just to make like tiles with no geometry, but with collision flags. And we fill them with these kind of things. The collision lookup, it's pretty much like the culling process in which you only collide with whatever's visible. So you peel back from view, like start from camera depth and move into the level until you hit something, and that's what you collide with. Same likewise, like if you see stuff that's see-through or immaterial, you would just keep going until you get something you collide with. Otherwise, like, since this is like a single point that's moving into the screen until you hit something, I had to do like point to world collision basically. And to make sure that he doesn't, like he has 3 collision points on his feet and then from the front of his face so his face doesn't go through stuff. And it's one axis at a time. You do it vertically and then horizontally. So what happens, like this works well, the moving through the grid, as long as everything's aligned on the grid, but it's stuff that can be offset. And trials actually have a cell in which they are. This is the point where the center is. So that crate is inside the purple cell there. If I'm trying to collide from like the front of Gomez, I'm not seeing it because it's not in the collision, it's not in the helper structure. So I need to look all the neighbor cells to make sure that they're there, which is basically an exception. And these are tests to show that like it works for offset stuff, for the trials with different sizes. It's still on the grid, everything's in a grid cell, but you would just look around to make sure that stuff is there. So Gomez, also another part of collision is how Gomez reacts to the 3D space since he's moving in 2D. So the movement is also in 2D, like if you move right relative to the screen and you would jump up. Well, up is always up. But it always needs to have a 3D space position. The level is still always in 3D. So Gomez should always stay visible, and you should never walk in midair. So if he does walk in midair, you just put it to the nearest tile. If he goes inside geometry, if it's flagged as background tiles, you would just push him away. So as long as it makes sense for the player to still see Gomez, and then when you rotate, you don't end up floating, that's the main goal. Otherwise, we don't want to touch his depth, because that means that, like, if you play with depth arbitrarily, the player really loses track of where he was or where he's going, and you lose that sense of control really easily. And there's something that we did differently in the past builds. In the IGF 08 build, we had that weird quick time event thing that if you rotated twice and ended up behind something, you would like, oh no, I'm not supposed to be there. I need to like hit a button and then it will turn back to where you were. How we handle this now is just you go in background mode, you're behind the structure. As soon as you move into view, you become visible, and then the collision works as you expect. It's also the music is low pass to give you a feeling that, hey, you're probably not supposed to be there, but it's okay. Like, you don't want to rush the player into doing something stupid. The lighting is handled with 2D planes. Basically, it's not point lights. We don't do any fancy lighting tricks, because usually for outside worlds, it's just ambient light or light from the sun, but the sun is not even directional light. It's just ambient light, basically. But we still have some cloud shadows. We have some positional lights for explosions, and these are all planes. The way they're rendered is I do a light prepass, which allows me to, like, if I draw the shadows, afterwards I can light up the shadows and not lose any color information. Because if I were to do everything on the like final color buffer, if you shadow something, you would reduce the amount of color information you get, and then if you multiply it again, then you get a lot of striping and weird artifacts. So it's good to do all the lighting and shadows before, and then apply it as a final step. I think that's true. I think Spelunky does that too. I've heard that on their blog. And it's a single texture, so not to have like a shadow buffer and a light buffer. I do everything in a single 8-bit textures, which is with colors. And then I blend it with modulate 2x, and what that does is that everything that's between like full black and gray gets shadowed, and then from gray to full white gets multiplied, so it becomes lighter, which is good. So the game has time of day lighting. This is a sped up 8 times as fast as it would be in the game. So usually like a good chunk of the day is daytime, and then you get dusk, and then night, and all of this coloring is based on that little tiny texture you see at the top. What I do is I sample a vertical stripe of that texture as the day moves, and move it across the texture. And this is the sky color. This defines the lighting color, the ambient light color, the tinting of the clouds, and everything. So it's very efficient just to use this as a easy manipulatable art piece, but also like a super tiny texture. So I'm going to talk a bit about the world interactions, the stuff that Gomez can do in the game, which he couldn't do before. Like at the IGF 2008 demo, it was a static world. You jumped around, and we had basically a proof of concept of the game as a climbing mechanic. But that's not enough to do a full game with. We quickly realized that you could have like maybe 20 minutes of compelling gameplay out of that, and that's not enough for the big game that we had in mind. So Gomez can now like do all these kinds of things, play with objects, move stuff around, things that make the world more interesting, and that allow for more complex puzzles of navigation and puzzles at all. So these are all manipulated with, controlled with action classes, and I'm going to go over what that means. So an action class is basically a chunk of code that knows when to come into action, that knows what to do when it starts and ends, and what it means to do, what it does in its active time. So this is basically to avoid doing a switch or a million booleans, like a big switch of every possible action that you could have. I don't know if people actually do this. I probably should, or I would if it were a smaller game, but as the game base grows bigger, it's good to have a system in which you can isolate code that does a certain thing. So I would have one for walking, for jumping, for interacting with any object or any action that you would think of. It's basically one sprite animation means one action class, and you can really like modulate code like this. So an example of really, like, I stripped down code from that, but so the walking and running class knows that if you're idle or teetering or pushing or looking around or whatever, and you're grounded and the player input, like, has input on the X direction, then you're probably walking, so it comes into action there. So they know when to come into action. I already said that. And yeah, it knows if it's still active. Basically, it's backed by enum. That's the action type. So you can have a chunk of code control more than one actual actions or more than one animation. And you know what's going on when they act. Like here, I would just transform the player input into physical impulses. I can also map different flags to a certain animation. So the animation texture, whether it prevents the rotation, so whether or not you can rotate the camera, or whether it's safe to respond in that state. Sometimes not. Like if you're dying, you don't want to respond and have a feedback, an infinite loop of you dying. So it's good to know, like, and it's really easy to do. So I'm going to talk a little bit about scripting, or how we approach scripting in FEZ. We have these things called actors, which are anything that's dynamic or interactive in the game. So they are groups of tiles or art objects or even volumes or volumes of space or planes in the game that do a specific thing. In that case, like these blocks would have like flags that would tell them how fast they move, or what's the frequency of their rotation. But it's not like it's all hard-coded behaviors that I would just tweak with parameters from the editor, which makes it really easy for me to write like a C# class to handle it without having to write a scripting engine to back it up. And you always have like those easy to manipulate for the designer or artist flags inside the editor. But we also have a scripting system because you can't do everything with actors. But it's like it's pretty bare bones. What I wanted is not to have a code view for Phil to use, because I knew that would be like ridiculous and scary, and you would do syntax errors, and then Renaud, what am I supposed to do? So basically, you can act on events that happen in the game, like whenever a level starts, whenever Gomez jumps, whenever something, and then act upon a certain condition. So if you, collected a cube and it's the 50-second cube, then something else happens. And you can do that game-wide per level. You can control camera, control tutorial prompts, or stuff like that. So this is what the script editor looks like. So it's all a bunch of drop-downs, basically, to avoid having to do actual code. And it's good because it's simple to manipulate, but it's also like more bothersome than I would find it if I had access to a code editor. So it's all triggers, conditions, and actions. Oops, let's get fast there, but yeah. So here's an example of what we could do with FEZ scripting. So whenever a level starts, I want to inform the player that a particular mechanic is used in that level, and dot is the tool to say that. So whenever the level starts, I remove the controllability from the player, so you can't move around and mess the script up. And then dot says a couple of stuff, and then you move to a point of interest. So these are all like a certain entity, and then a certain action, and then a couple of parameters. And all the actions are executed in sequence. They're all blocking, which is and I want to define that this particular script only happens once in the game, so we don't get told the same thing every time. So this is the kind of thing you can do with scripting. And all the drop downs that you saw in this one, like entity type, operation, property, those are not populated by hand. These are actually reflected from all the scripting interfaces that I would do in the engine. So I know that there is a level, it is a service, it publishes all these public events, public properties and operations, which makes it pretty easy to add more stuff and then have it instantly reflected into the editor. The level format, so how we used to save levels and how it's usually done in XNA is to use the XML serializer. XML worked for a while, but then we realized that FEZ levels are made with all these little chunks, like a lot of trials, and it makes a really huge, like a couple of megs wide XML file with just these position lists, which is ridiculous. So I tried to find a simpler or a format with less overhead, and I looked into simpler data languages like a YAML or JSON. And I found this SDL, which is not the SDL that you would think of, but it's a simple declarative language. And it's really well integrated with .NET, and I'll show you the output that it does, but that's what I ended up using for all the design time levels. At compile time, actually, for the game, it's compiled to a binary format, because even parsing SDL, it's kind of too slow for comfort on the Xbox. So SDL looks like this. It's basically like, take everything that you don't need from an XML file, and you get this. So, like, if it's a single element, you would just put it in line. Like, the name is Arch. There you go. You don't need to do like and starting tag, close tag. And for a dictionary, is it like key? Usually, I would have a single value key. So it makes a really compact data representation, and I think it's great. Yeah, all the vectors also, like, usually you would have a position X, Y, Z, 3 separate tags for these. Instead, like, it just collapses to a single thing. The music is a big part in FEZ. If you've heard trailers, we tend to put that at the forefront because it's really adds a lot to the atmosphere and defines the game in many ways. Disasterpiece used this tool that I made it's all in Feather. It's all different modal forms from Feather, but it's the music system. And it's written on top of Exact because it needs to work on the Xbox, and Exact is the simplest way to do that. And what it allows for is infinite dynamic track-based songs. What that means is that a song would start and then it would morph as it goes. It could remove elements and add elements depending on scripting events like moving through a level or moving through several levels. And it also works with time of day, in which you could say like a certain track is only enabled for daytime or nighttime, which makes for a really interesting song generation. And I'm going to demonstrate that if I can get my mouse cursor there. There you go. So this is one of we call it the puzzle solving music, but it's interesting because it's a cycle. It never ends. So at the very beginning, you have this main arpeggio, which starts and it's a sound file. It's 8 bars long. And once it's finished playing, it would just wait for between 0 and 16 bars and then play again. But it could be any measure of time. So that means that the song will just be continually different because of these random intervals of waiting time. I guess I'll just leave the song play. But at one point, the main arpeggio will come back, but we don't know when. It just comes back by itself. Oh, anyway, here it is. And this music would be like, depending on when the dust comes in, tracks would fade out, other would fade in. And it's always following that random sense of, yeah. So, yeah. I'm going to talk a little bit about optimization in FEZ and how it's been a challenge. So XNA in the Xbox is cool because you can do managed code on a console, and it's been a really good initiative from Microsoft, but it also means that they're using all these tools that allow them to run managed code on the Xbox, like the .NET Compact framework. And that means that you really got to be really careful about garbage generation. Every time you allocate something that's thrown away, you actually risk the game locking in the middle of gameplay for like a really short time lapse, but it makes the game really jittery. So there's ways to find where the garbage is generated and avoid it, but you need to think about these things. The draw calls are really expensive, so that's why I had to resort to batching. But you need to batch absolutely everything, because every draw call holds you back. So initially I thought, okay, I'm just going to instantiate the trials, but then I had to instantiate the art objects, all the planes, everything, even like that dot ended up being instantiated because all the faces, I had to batch it together basically. Also, so the CPU, there's 5 of them, they're slow, but you need to use them to exploit the power of the console, basically. The hard drive access also is surprisingly slow. I would think that disk-based games would have less problem, but even Xbox Live Arcade games that reside on the hard drive have a lot of problems with content loading and how long it takes to just access the thing because of a lot of the security things that are onto the hard drive. And flash access is even worse because now we can put a game onto a USB stick and save it on there, but it makes the game even longer to load. So what I did to avoid that is to preload all the game at the beginning as the splash screens are loading and have everything in memory so I can access it later. I thought this would be like a waste of memory, but usually like you don't have 500 megs of content, especially not with FEZ. So preloading everything is an option. It makes the game run a lot smoother later on, especially if you have threaded loadings. So one of the tools I use to find out where garbage is generated and how to avoid it is the CLR profiler, which is a really handy and free tool. It's pretty old, but it still works with everything.net. So what it gives you is allocation graphs of where stuff starts being allocated, and then basically it shows you like from the main starting point, it splits up all the allocation until the very method they're allocated. And it gives you also the memory usage by class. And yeah. So how you use it is you start the game with the profiling on. You just wait for 20 or 60 seconds, not touching the controller, not doing anything, and then check the report. So then if it's garbage, it's generated at runtime, and it's not even dependent on user action. You also need to profile the CPU because the CPUs on the Xbox are not that great. So it's good to find also, like, even when doing PC apps, you don't optimize if you don't know what you're optimizing or why it's actually worth it. It's pretty much essential as the program goes big and you lose track of all the modules and everything to use something like, I use the ANTS performance profiler, but there's also AQTime and dot trace, which are really good to find the bottlenecks and where you actually need to spend time optimizing. It's sometimes surprising. Like, at one point, the explosions were slow in FEZ. I thought it was the particles, because it makes sense to think the particle generation is slow. But it was actually too many sounds created at once. But you don't really know that unless you have really good tracking tools, or at least you can analyze it with a profiler. And also, on top of the CLR profiler, to analyze the memory usage, it's good to have something that gives you more insight into what's going on, because these graphs that I showed for the CLR profiler are cool, but they don't have a lot of, it gets overwhelming fast. So what I use is the Scitech.net memory profiler, and what this does is you start the game, and then you get a snapshot of the heap, and then it gets everything that resides in the heap, so that everything has been allocated. It takes a snapshot of this and keeps it in memory. And then you continue playing the game, do a couple of level changes, move on, and then you retake another snapshot and you compare the two to see what's been unloaded, what's been like stayed in memory, what's leaky basically. Because you don't think maybe in C# that you would have a problem with memory leaks because it's a managed language, but you totally do. Everything that's cached or everything that you forgot to deallocate will stay there and garbage collector will never take it and you'll never get any, like it's easy to forget about these things. It also gives you insights on if you had disposable objects that are not disposed but garbage collected, or disposable objects that are not garbage collected, stuff like that. So if you develop a game for Xbox Live Arcade with XNA, you've got all these tools, but none of them are usable. There's, some of them, but most of them are really geared towards native code. So I used XB Watson, which is basically a debugger, the debug console hook for the Xbox. So I can log everything and then it appears in my PC console. So that would be useful, but still limited because it's still text. It's like you would use a console on your PC app. There's also Pix, which is not part of the XDK, but it also comes with it. You can get it elsewhere. And it's basically, you can capture a single frame and look at what's taxing the GPU on it, which is really good for debugging shaders, looking what's slow in a single frame. It's pretty impressive in that regard. But there's a CPU performance profiler that's just not usable for .NET. It doesn't give you anything, and you can't really, so that was kind of a bummer. So my experience with XNA XBLA, the fact that FEZ was such a long project meant that we kept like upgrading and getting like bugs fixed, but that I fixed myself. Well, stuff that I had to revisit, or even like the feature changes or the way that stuff worked in the earlier version just changed, and I need to keep up with it, which is, well, I guess natural. But one of the problems we hit is that you can't really use any native library on XNA, on XBLA, on the Xbox. Which means if you're not satisfied with the sound library or the movie media player or something, you don't really have any other option. You can't use Fmod, you can't use Bing Video. You have to put up with whatever tool they provide you with, which was a problem for us. Yeah, and there's more, like you hear about TCR nightmares for Xbox games. It's maybe less bad for FEZ because there's no multiplayer. There's a lot of things that we don't do, which makes it simpler. But some of the really base stuff, like bugs with, like if you disconnect from Xbox Live without losing your network connection, your profile signs out and then re-signs in, but you have to look for that particular case of sign out, sign in as not an actual triggered sign out. Stuff that seems to be legacy from, like, I don't know, old design decisions that you still have to work, and I guess every developer for the Xbox needs to think about, which is kind of weird. And you don't get any samples for debugging .NET assemblies so if you run the game in release on the Xbox and it crashes to the dashboard with a really bad crash, you can't really debug that because you don't have any symbols for anything. But on the other hand, like, I never could have done FEZ in another thing because it's a question of comfort. I'm not a C++ expert, and it's great that it enables like people that come from the managed world, and I feel really comfortable in that state to make a game on the Xbox. And also the translation from PC and Xbox is really easy. So what did I learn from FEZ development? Like, it's easy to say, like, I would do it completely differently, but it's also hard to say that because FEZ was my first project. It was my first big game. And it's really hard to finish. It's not... If you care a lot about your project, like, I guess Nathan put it in better in his talk today, but it's just it's hard to manage your own... the fact that you want the game to be perfect, and the one that you don't feel ready to show it. Sometimes it's worth to just wait and to make it as good as you think it can be. So we showed the game really early, or at the IGF, which was a lot of attention and put us on the map and made us realize that we needed to make something bigger out of it. But also everyone kept pestering us about, why isn't this not out? I felt like this was done. It's been like 3 years. But like, we didn't feel like it was ready at all, so we waited, and then when we later showed it again, people remembered it, and it's really good to see like everyone giving good feedback about it, and so I'm not even sure what to take from that. And the one thing that really got bad in FEZ is feature creep, but I kind of learned through other like short form games. I got into game jams as I was developing FEZ, and getting that sense of closure around the project after a weekend or like a couple of days really gives you the idea of, okay, what do I need to cut because I need to finish the game now. So I would really encourage everyone like that wants to make an indie game to get into game jams and really learn how a game needs to be finished. So if I had to do it again, I realized afterwards that making the engine, the tools, the game at the same time is way too much work. Either I would hire someone that's more proficient than me to do an actual engine and something that's reusable, which would benefit the company in the long run, or just use something that's already there. The tools are so good now. Every time I do a game jam, I use Unity, and I've never like regretted that. So I would definitely look into Unity, and I do feel that FEZ is doable in Unity. Why not? I think our scripting engine was very geared into me doing all the hard code and then Phil playing with knobs, which was, I felt, the good idea, but then it's so much workload, so it's good to be able to educate, like make a real scripting engine that's probably stripped down and very like intuitive, but get your artists to use them. So that's probably what I would go for. And also, FEZ from the day one still has code from like April 2007, which is sort of ridiculous when you think about it, but I think it would be better off to, like, the IGF-08 was a prototype. We got something good out of it. If we really had the foresight of thinking, like, okay, this game is going to come out in 4 more years, you got to realize that it's a big project, that it's worth the effort to just scrap everything and come over again. And I am done. Yeah. So I've got 10 minutes for questions, so if you got anyone. Or run to Indie Game the Movie and I will not be sad.
Hi, I wanted to know, when you were talking about the audio and you had the music engine, did you encounter any problems with timing? Like, did you have multiple cues playing at the same time to create the music? Because I was running into those issues when doing an XNA.
I did have multiple cues playing at the same time. That's because Exact allows this, but you can't use the music player stuff to do more than one track at the same time, so we had to use Exact. The sequencing stuff, the timing, keeping time, has been a problem, but it's not unsolvable. You just need to know exactly when the songs start. But the thing is, you can't have a heartbeat of the music system as it goes, or I haven't found a way to get it. So it's really like singing it at the beginning and hoping for the best. Yeah.
And it's worked, though?
Oh, yeah.
Okay, cool.
Hey, can I get this microphone?
Hello.
Hey, guys. Hold on, turning it.
What is that?
Microphone?
Hey guys, whoa, Jesus Christ. Hey guys, if you are leaving, please just hold your chair like murmuring for the hallway. It's kind of really distracting. Thank you.
Hello. Yeah. Oh, there you go.
Oh, whoever.
Okay. So I was just curious, as a single programmer, where you drew the line in, hey, Gomez can jump around, he can collide with things, like we could make everything be able to collide with things, or like how do you draw the line between making the engine and making a very specific bit of code that, because it's only going to happen once, but...
Once you mean in one project? Because the FEZ engine is the FEZ engine, like it won't be reused. That's kind of the whole thing.
I meant across the game where...
Okay.
Yeah.
Well, basically it's a design question, because if you want to do something that comes back in the game, you want to like make a string of levels that use it, and then the design came from Phil, but we had a list of features, like essential stuff, nice to have, and then stuff that's really like icing on the cake. And it's based on how we wanted the game to evolve. Like we had this idea about different worlds, like an industrial world, a nature world, all these things, and a set of mechanics that went with each of them. And we dropped stuff that we didn't have time to do, but it's all like based on the design.
Are you considering releasing your tools?
I don't think it would make sense. First, because they're really hard to use, because they were geared for the two of us. Also, because it's not a game that hooks content into it easily. It's a very self-contained world, and like unless you're making a total conversion or something, I don't know. I know that like id Software releases their tools for their games 10 years after, so why not? That would be cool.
Looks fun.
Yeah. Do you know any good forums or reference sources for XNA, especially shaders?
I missed the beginning.
Any good forums or sources for XNA?
There used to be a site called ZiggyWare, but it's dead. There's the create.xna.com forums. What did I use? Well, usually your questions when you're developing are programming questions, and you can get really good answers that are not XNA specific on stuff like Stack Exchange. I felt like just Googling anything that even though it's not, like you're doing a game, the fact that it's XNA, it's not very specific.
Yeah, all right.
That's my way of seeing it.
Why was the decision made to transition from a PC game to an Xbox game, and how has that worked out with your process?
Well, the idea is the FEZ is always meant to be played with the controller. There's a lot of stuff that's relative to controller, like usage of probably shouldn't go too much into it, but there's a lot of stuff that are very controller-centric. The game feels good when you're playing it on TV with a controller. So from day one, we thought like it would be a good option. I guess we chose XNA from the beginning, hoping to bring it to Xbox, and then it happened that it was possible for us. So, and we can't expect every person with a PC to have an Xbox controller or even a controller that has all these buttons. So it's a redesign at this point. Yeah.
Hi, I was wondering if you could explain why you decided against using XNA4.
We decided, well, we always felt like we were really close to release, and when XNA4 became you probably need to use XNA4 from Microsoft, we said well, the game's done, we just need to debug it. So it would be stupid to just get all those changes implemented because there's ways that the content pipeline is different, and it was scary for us to upgrade. And we basically signed an agreement with them saying we don't want to upgrade because it would mean too much more QA.
If you had the option of redoing the game with 4, would you use 4 or would you use 3?
Yeah, why not? It's just a matter of the workload that comes with the upgrade. But from now, 4 is fine.
Okay, thanks.
Maybe I'm wrong, but it seems like I haven't played the game, but it seems like what I've seen in the gameplay, much of it could have been achievable as a 2D game with just complex sprite transformations to fake the 3D element. Am I wrong? Or I'm sure there's some lighting things that would have been capable. I was just wondering in retrospect if that would have been achievable.
Do you mean instead of using all these blocks of geometry, it would be sprites?
Yeah, I just wonder if...
It would look awkward. But I mean, the mechanics would be doable. But the fact is that the world is always in 3D. And it's like a big sculpted shape that ends up being cubic. Mm-hmm. And we're just seeing that shape in different views. It really makes sense in 3D. I don't know if you've seen the neutronized game Sky Island, which we kind of... it came out maybe a year ago, and it's a Flash game that uses the same kind of rotation mechanics, but you drag the mouse around instead. Mm. And there's all the planar shapes because it's a Flash game. It's less resource intensive. Mm. It looks different. It's not the same feel. Okay.
I was wondering if you could go into more depth about the challenges you faced as a programmer and designer, two-man team kind of thing.
What in particular?
More specifically, working together with your designer to implement new features, as he comes up with the idea and designs the game more fully.
Yeah, well, we started with a base feature set that we got implemented pretty quickly, and that was the Agile prototype. And we had this wish list of, hey, it would be nice to have crates and vases and destructible environments and whatever. And then as we went, it started making less and less sense to build some of these stuff because the design needed to be simplistic to be playable and achievable. But as a programmer resisting these, or I feel like I went over it already. I don't know what to add, really. Sorry. One more question. Yeah?
So as a member of a two-man team, a problem I have learned comes up sometimes is one member has a bunch of work to do and the other member doesn't have anything to work on at all, and that just creates this motivational black hole where the one person isn't doing anything and might feel crappy about that, and then the other person feels
yeah, there's always downtimes. Usually how we worked is that he said, I'd like to make levels for this area, which requires these mechanics. And he would work on the mechanics that were already implemented as I'm working on stuff that's, I'm always one step ahead of him.
So just try to avoid bottlenecks rather than deal with them.
Yeah. But I'm always working on stuff that he's going to use the next week, which kind of negates the downtimes.
So that there's never a...
Well, there is. Wow. At the end, I'm debugging and he's making PR, but that's still working.
Yeah.
But I think that's it. But thanks a lot.